Alright, so here we have a couple of problems involving complex numbers. Let's look at number 1. So we see I times negative 5 plus 7I plus 8I times negative 7I minus I. So let's do the left half of the equation first. So we have I, negative 5, plus 7I. So for reference, just to make sure, I is defined as the square root of negative 1. Thus, I squared becomes negative 1. Now, I is known as a complex number because it doesn't exist in the real numbers plane. It's not an integer or a real number. However, it does have some pretty interesting uses in some parts of engineering. But for the time being, let's just do some practice with this. So I times negative 5 is going to be negative 5I. I times positive 7I is going to be positive 7I squared. And we know that I squared is equal to negative 1. So the left side of the equation is going to be negative 5I minus 7. Because again, I squared is equal to negative 1. And it's going to be essentially positive 7 times negative 1, which is going to give us negative 7. So this is the left half of the equation. So we have that. Let us clear this out for some space. I'll rewrite it over here. Alright, so now let's look at the right half of the equation. We have 8I times negative 7 minus I. Awesome. So when we multiply this, the 8I times negative 7 is going to be negative 56I because 8 times 7 is 56. And then 8I times negative I is going to give us negative 8I squared. And once again, I squared is going to be equal to negative 1. Thus, this goes from negative 56I minus 8I squared to negative 56I plus 8. And the reason why it's plus 8 and not minus 8 is, see this sign right here? The negative 8. Well, if I squared is negative 1, and we're doing a negative 8 times a negative 1, we're going to get a positive. So it's going to go from negative 8I squared to positive 8. Alright, so that's the left half of our equation. So we have negative 5I minus 7 plus negative 56I plus 8. So we can combine like terms, and because I is a variable in this instance, it's also a value, but for the order in which we write a solution, we're going to put I first as if it was a variable, just like you would in the form ax squared plus bx plus c. You're going to write the highest value variable, so we're just going to treat I like a variable. So it's going to be negative 61I because negative 56 plus negative 5 is negative 61. And then we have negative 7 plus positive 8, which is going to give us 1. And that is going to be our solution for the first problem. Now let's take a look at the second problem. This is going to be more of a FOIL distribution, just like you would with any kind of binomial expansion or multiplying two binomials together. So let's remember the FOIL method. So it's going to be first, outer, inner, and then last. So it's going to be the first, oh, sorry, did that wrong. The first, the outer, the inner, and then the last. Alright, so now that we have that, let's clear this up for some space. Let's look at the first terms. 6 times 7. Awesome. 42. So that's done. Inside, or outside. outside 6, and positive 8i. So 6 times 8, 48. Let's not forget that I though. So that's going to be plus 48i. Let me write the I a little bit better this time. There we go. Plus 48i. Awesome. So we did outside. Let's do inside. 4i times 7. That's going to be 28i. 4 times 7 is 28. Don't forget the I. Now let's look at the last. So it's going to be 4i, positive 4i, times positive 8i. So 4 times 8 is going to be 32. And the I variables, we know that if we, for instance, if we did x to the first power times x to the first power, we're going to add the powers. So x to the a times x to the b is equal to x to the a plus b. It's the same premise with I, because essentially what this is saying is that these i's are to the first power. So now we're multiplying I to the first power times I to the first power. It's going to be I to the second power. So again, 4i times 8i is going to be 32i squared. Awesome. So let's do this first, because we know that I squared is negative 1. So what this essentially does to our problem is it converts this to minus 32 and just negative 32, because again, when this is evaluated, this is going to be negative 1. Alright, awesome. Now we can combine like terms. So 48i plus 28i is going to be 76i. So let me write that right here to make it a little easier for us. And then the 42, it's positive, so plus 42. So we have 76i plus 42 minus 32, so it's going to be 76i plus 12, because 42 minus 32 is 12. And that is going to be our solution for problem 2. Let's jump ahead and do problem 5. So we see that it's an I times an I, but we must take into account that this, since we're doing an operation with parentheses, we have to do this first. So we're going to keep that I on the left side, and we're going to focus on this side of the equation. So it's going to be negative I times 4, and then negative I times negative 7i. So negative I times 4 is going to be negative 4i. And then negative I times negative 7i is going to, so negative times negative is going to be positive 7i squared. Alright, awesome. Now we can focus on doing our PEMDAS left to right. We've done our parentheses. So since this is next to it, and this cannot be simplified any further because we're dealing with a real number and a complex number, you cannot simplify these two. They're as simple as can be. So we had to multiply this negative I to each of them respectively. So now we are going to multiply So now we're going to multiply the outside by the inside. So now we have just I times negative 4i is going to be negative 4i squared. And then we have I times positive 7i squared, and that's going to be positive 7i cubed. So let's reflect on this. So it's I cubed, right? So typically when we do with cubed in normal numbers or real numbers, let's say x cubed, and we know that kind of looks something like this on a graph, right? But we know that x looks like something like this on a graph. Well, this is the real numbers graph. When it comes to I to the third power, we must keep in mind one more time that I is going to be equal to the square root of negative 1. So basically what happens is you have this kind of pattern that repeats itself, where it's never going to escape this kind of loop, where we have I to the 1 being negative 1, and we know I squared is negative 1. But if you multiply I cubed, so we have square root of negative 1 times the square root of negative 1 times the square root of negative 1. We're going to be left with negative 1 times the square root of negative 1. So it's just going to be negative I. And then when we square it again, so we have negative I, so it's going to be essentially negative I times I, which is going to give us positive 1. And why is it giving us positive 1 instead of negative 1? Well, if we take a look, we have our negative 1. It evaluates to negative 1 when it's squared, and then it becomes negative 1 times square root of negative 1, and then it just becomes negative I. And then when we go back, it goes to positive 1. And then this cycle repeats itself, because now we just have 1. So we have I to the 5th. It's just going to be 1 times square root of 1, and 1 can be omitted, because 1 times anything is the number itself. So now we notice that it kind of cycles through, where I to the 5th is the same as I to the 1st, which means I to the 2nd would be the same thing as I to the 6th, I to the 3rd would be the same thing as I to the 7th. So it's important to note these first 4 powers of I. And then once the power of 4 goes to power of 5, it's just going to loop back to as if it was I to the first power. So that's something to keep in mind for future problems if you ever do I with a lot of exponents. So now we have, again, I times negative 4i being negative 4i squared, and then I times 7i squared being 7i cubed. So now we can evaluate this. We know I squared is negative 1. We have a negative 4. It's going to be 4. And then we have 7i cubed. So what this essentially breaks down to is minus 7i. Because again, I cubed is the same thing as negative I when it's solved. So that is going to be your answer for the third problem.